Then we move on to feature scaling. So from scalar and preprocessing, I imported a standard scalar, min-max scalar, and robust scalar. X is equal to df preprocessed dot drop diabetes x is equal to 1, and y is equal to df processed brackets diabetes. Basically, this prepares the data for scaling. Numerical columns equal to age all the way down to blood glucose level. Basically, this focuses on like numerical features for like scaling. Then we move on to x standard scaled equal to x dot copy all the way down to x robust scaled equal to x dot copy. Basically, this creates like a data frame to like store like the scaled features. Next, we move on to standard scalars equal to standard scalars, x standard scalar scaled brackets numerical columns equal to st scalar dot fit transform brackets x or brackets numerical columns. Basically, this uses standard scaling using like the z score zeros normalization. Then we move on to min-max scaling. So min-max scalar is equal to min-max scalar, x min-max scaled, brackets, numerical columns, brackets, min-max scalar, dot fit transform, parentheses, x, brackets, and numerical columns. Basically, this applies min-max scaling and basically normalizes the range from 0 to 1. Then we move on to robust scaling. So robust scalar is equal to robust scalar, x robust scaled, brackets, numerical columns equal to robust scalar, dot fit transform, parentheses, x, brackets numerical columns. Basically, this applies numeric robust scaling. This allows it to be less sensitive to like outliers in the distribution. Next, we move on to visual comparison of scaling models. So we did plt.figure is equal to fig size 12 to a, plt.subplot 2 to 1 all the way to plt.title original blood glucose level. So this plots down the original blood glucose level. Then this line of code basically plots down the standard scalar version of the distribution. And then this one plots down the min max scaled from the range from 0 to 1. And then this one plots like the robust scaled using like interquartile range and like median. So here we have the four graphs. So this is the original blood glucose level. Then we have the standard scaled distribution. And then we have the min-max scaled from the range from 0 to 1 as seen over here. And then we have robust scaled using like interquartile range and the median for this distribution. As you can see, all of these like plots are basically like right skewed distributions, and like all the scaling methods like maintain like the overall shape of the blood glucose distribution. Now they have like the similar like peak across like the four plots of like around here ish. However, each one has like a different x-axis values. So yeah. Then we move on to x scaled is equal to x standard scaled dot copy. Basically, we're using standard scaling for future analysis, mostly because many of the machine learning algorithms perform better with like standardized features such as like a logistic regression and random forest classifier, which we're going to use later on in this project as they benefit from like standard input features. So yeah.